All right. Greetings, scholars. I hope everyone had a great weekend. It was productive, and you were able to do what you needed to do, get some rest, get your work done, get caught up, position yourself for success. Let's see. No real announcements other than everything's going to kind of come to a close rapidly, right? This week, we're going to be working on section 2.3, dividing polynomials and the rational zero test. Matter of fact, well, I guess we did. And then so this Sunday, exam 3 should become available. And that'll be over those the first 3 sections in chapter 2. So 2.1, 2.2, and 2.3. So then next week, we'll just use it as a testing week. We'll either work, more than likely, I'll just make myself available for questions. But this week, we'll focus on section 2.3. Okay, as usual, if you have questions, feel free to unmute yourself to get my attention. If you email me, just kind of get my attention towards the end of class so that, if we need to talk about it, we can. And let's kind of get into the topic. All right, so again, this is going to be the last section for chapter 2, polynomials and rational functions. And we're going to be working on section 2.3, dividing polynomials and the rational zero test. A few objectives: 1, learn the division algorithm. 2, use the remainder and factor theorems. 3, use the rational zero test. So we have this thing called a polynomial factor. A polynomial d of x is a factor of a polynomial f of x if there's a polynomial of q of x such that f of x equals d of x times q. Let's see. Dividend, quotient, remainder, divisor. Let's see how it unfolds. If a polynomial f of x is divided by a polynomial d of x, where d of x is not, that's usually the dividend, right? The divisor. The dividend is the result. Okay. Let me think. Divisor. The quotient is your answer. Okay. I'm just trying to straighten out like the terminology. Basically, this is like polynomial long division. And so the same way you do regular long division, where you have like, where you do long division, those same rules apply here when we do polynomial long division. We're going to see our dividend divided by our divisor, right? Our dividend divided by our divisor. The answer is going to be our quotient, and then we might have a remainder, right? But all of these can be expressed as polynomials. We can, those same operations we do with numbers, we can actually do them with polynomials, okay? And same rules apply where the divisor, the denominator cannot be 0, right? We can't divide by 0, okay? All right, let's see if we can see this in action. Use long division and synthetic division to find the quotient and remainder when this dividend is divided by this divisor. We will start by performing a long division. I need some space. Did I give myself some space? I don't see any. This is slide 6. Let me do like 2 pages. Select. Duplicate. Let's just move this down. Right here. And let's duplicate it one more time. Okay. All right, I'm done with this. There we go. Let's grab this guy. All right. Let me start by getting a copy. So we have this, 2x to the 4 plus x to the power 3 minus 16x squared plus 18 we want to say divided by x plus 2. Okay. All right. So let's perform this operation. Our dividend. Now, the first thing is when we're writing this out, we need to make sure that every power is accounted for in our dividend, right? So, yeah, I think I'm saying that right. We got power of 4, power of 3, power of 2. Notice the power of 1 is missing, right? So we need a placeholder here, okay? So our divisor is this x plus 2. We're dividing into 2x to the 4 plus x to the power of 3 minus 16x squared. Again, we're missing x to the power of 1, so we're going to say plus 0 x to the power of 1. You don't have to write the 1, obviously. I'm not going to write it. But, x to the power of 1 is our placeholder, and then we say plus 18. Okay. So then when we go to perform our operation, we're going to say the first divided by the first, right? So our first term is 2x to the power of 4. We're going to say that divided by x, and we're going to put our answer up above, lining up our like terms. So 2x to the 4 divided by x is going to be what? 2x to the power of 3. 2x to the power of 3. So first we said the first divided by the first, then on the diagonal we multiply. So our next thing, just like in regular long division, we multiply. So we're going to multiply here. This 2x to the third times x is going to be 2x to the 4. And then 2x to the third times 2 is going to be what? 4x to the third. Okay. And then just like in regular long division, our next step is subtract, right? Subtraction. So we're going to distribute a minus across here, right? Basically, we have to flip those signs. Okay. So then if we subtract, it looks like this cancels. 1 minus 4 is going to be -3. So there's going to be a -3x cubed. And then the next term comes down. And we repeat that process. Okay. So now we're back to saying the first divided by the first. So -3x cubed divided by x is going to give us a -3x squared. -3x squared. Notice how I'm lining up my like terms. I'm lining up my like terms. Okay. So then on the diagonal, when we go in this direction, we're multiplying. Okay. So then we're going to say -3x squared times x to give us -3x cubed. We get a -3x cubed. -3x squared times 2 is going to be -6x squared. -6x squared. And then again, we need to distribute our negative. So basically, we'll be flipping our signs. So if we distribute a negative, those both become positive. Okay, I'll check attendance again in just about 5 minutes for anybody that's running late. We combine like terms. The first term, a number plus its opposite, these guys add to 0. -16 plus 6 is -10. -10x squared. Then we bring down the next term, which happens to be our placeholder. Okay. Okay. Then we repeat the process again. -10x squared divided by x is going to be a -10x. It's going to be a -10x. On the diagonal, we multiply. So -10x times x is a -10x squared. -10x times 2 is a -20x. And then we distribute our negative. If we distribute our negative, this becomes positive, this becomes positive. All right. A number plus its opposite, these guys add to 0. 0 plus 20 is itself, 20. 20x. And then the final term comes down. And this should be the last iteration. So we say the first divided by the first. So 20 divided by x gives us what? Just 20? Or 20x divided by x gives us 20. And then on the diagonal, we multiply 20x. and that's a plus 40. We distribute our negative, so this becomes negative, this becomes negative. A number plus its opposite, these guys add to 0. 22, negative 22 is our remainder. Okay. So when we say this dividend divided by this divisor, our quotient is this 2x to the third minus 3x squared minus 10x plus 20. We have a remainder of negative 22. Another way we write the remainder sometimes, we're going to say the remainder over the divisor. So there's negative 22 over x plus 2. Okay. And then that's going to be it right there. Okay. All right. So that was a showcase of polynomial long division. So then we have this other technique that's called synthetic division. We can use synthetic division whenever our divisor, the thing we're dividing by, is a linear binomial, right? We're dividing by x plus 2, that is a linear binomial, so we can use synthetic division. Let me get a copy of this, and I'm going to showcase synthetic division. Let's copy, paste. Delete. Okay. So with the synthetic division, again, we can do synthetic division whenever we're dividing by a linear binomial. So then the first step is identify the 0 of that linear binomial right here. So what value of x makes this guy 0? Well, in this case, negative 2 makes this guy 0, right? So then negative 2 goes in our chair. Okay. So then we need to take our coefficients of our dividend, again, making sure to incorporate any placeholders as necessary, right? So we got the same little thing. So if we take the coefficients, we got 4, 3, 2. We're missing the power of 1, so we're going to need a placeholder there. We got 2, 1, negative 16, our placeholder, and then 18. Without that placeholder, your chances of getting it correct are practically 0. Right? Okay. So then now, this is the setup for synthetic division. Again, we're dividing by a linear binomial. We put the 0 of the linear binomial into the chair, and we take our coefficients of our dividend, making sure to incorporate placeholders as needed. So then the first step after this, that first coefficient, it just comes down. You just bring it down, okay? Then whenever we go on a diagonal, we multiply. Whenever we go vertical, we add, all right? So now we go on a diagonal, negative 2. Negative 2 times 2 is negative 4. So we put our negative 4 here. Vertically, we add, that adds up to negative 3. Diagonal, we multiply, that is a 6. If we add, that's a negative 10. Diagonal, we multiply, is 20. Vertically, we add, is 20. And then diagonal, we multiply, that's going to be what, negative 40. And vertically, we add, that's a negative 22. And that negative 22 is our remainder. Okay. So then, since we started with a degree 4 polynomial, this result, this quotient, is what's called the depressed equation, not because it's sad, but because it drops down by 1 as far as the powers, right? So since we started with the power of 4, this is now a power of 3. So 2x to the power of 3 minus 3x squared minus 10x plus 20, okay? And then I think that's the same result that we got from before. 2, negative 3, negative 2, negative 3, negative 10, 20, 2, negative 3, negative 10, 20, right? So again, synthetic division obviously is like a lot more simple to do than polynomial long division, but we don't always have the luxury of using synthetic division at our disposal. Let me pause for a moment. I feel like there should be questions, but you know, I don't stress you guys asking questions anymore. I let you, decide for yourself. I just try to make myself available. Let me kind of update my attendance for latecomers. He must have cut proved it. Or he's changing devices. Okay. And then the other thing, as far as announcements go, just make sure that you all are, working on your lab, the lab component with Dr. Lamar. That you're responsible for that. Now, wait a minute. Do I have some doubles in here? How is it so off? Let me check my attendance. Let me see. Oh, I don't know how he got in here. I think some people got in the first wave that didn't get credit. Let me just try to find the people. New. Yep, there's another one almost there. How many more are we missing? One more. Okay. New. Got him. New. Wait a minute. Unless is there a double? So no, one person I definitely let in. Oh, there he is. I found him. Yeah, I think what happened because I clicked on admit all. I think some people got in just as I clicked that button and it didn't get credit, but I caught them. Man, I really enjoy taking attendance in Blackboard because it's extremely user friendly versus like Starfish. Starfish is like not user friendly at all. Okay, this looks a lot better. It says 20 present. I got 21 participants. Yes. Okay. Let me bring this back, share my screen. Okay. Hey Siri, turn the heater off. All right, so this looks good, right? We got the same result with the same remainder, right? We saw two different ways of doing the same thing. Seamless, and then okay. Let's keep going. Right, and then here we have a type version of what we just experienced, right? And they essentially did the same thing that we did. Let's keep going. And then synthetic division. Okay, let's keep going. So if a polynomial f of x is divided by x minus a, then the remainder is given by, so this is called the remainder theorem. Okay, so if we have our dividend divided by our divisor, one way to jump straight to the remainder is we can evaluate f of that zero of the, like we put in the chair for synthetic division. Yeah, right. The zero of the divisor. The way I remember dividend, like if we go back, let me go back real quick. Like for instance, in this polynomial long division, when we're setting it up, the dividend is at the end, right? It's inside the long division symbol. So that's why I keep pausing, because in my mind I keep saying, okay, dividend is at the end. When I say the end, I mean it's like this guy here, right? It's at the end, right? So the dividend is at the end, then you have your divisor, your quotient, and your remainder, right? Okay. That's why I keep pausing, trying to make sure I'm saying that properly. And like, if you just practice saying it that way or like using it properly, then it becomes second nature. I just don't ever practice it. That's why it's so like broken and the rhythm is so weird. Again, the remainder theorem, the remainder is going to be equal to f of the zero of the divisor, right? And vice versa. You can go in both directions there, right? So find the remainder when this polynomial is divided by x minus 1, right? So now, obviously, we can do either polynomial long division or synthetic division, or we can just use the remainder theorem where our zero of the linear binomial is going to be 1. So we evaluate this function when x is 1. So for our remainder, using the remainder theorem, is going to be f of 0 in this case, f of 1. So that's going to be a 2 times 1 to the power of 5 minus 4 times 1 to the power of 3, 5 times 1 squared, 7 times 1 plus 2, right? So then that's going to be 2 minus 4 plus 5 minus 7 plus 2. Okay. Let me see. That's a 9 minus 11 is negative 2. Negative 2, that's 3, negative 4, negative 2. Okay, so we found a way to jump straight to the remainder when our dividend is divided by our divisor. What if, let's see how else it can evolve. Given this function, find f of 3, right? So then if we try to evaluate this, we're going to get massive numbers. It can be, a bit of a challenge. Instead, what we can do is do synthetic division where the negative 3 is in the chair, and then the remainder is going to be f of 3. All right, so we can invoke the remainder theorem in the other direction. Okay, so here, again, we're going to put negative 3 in the chair. We take all our coefficients to make sure to incorporate placeholders as needed. So our coefficients are going to be 1, 3, negative 5, 8, and 75. Okay. Power of 4, let me see, 1, 2, 3, 4, 5. Okay. So then if we do synthetic division, remember the first one just comes down. On the diagonal, we multiply. So that's going to be a negative 3. Vertically, we add. Then we multiply. We add. We multiply. We add, what is that, 23? We multiply 69, and then 6 is our remainder, right? So then what we're saying is that, nope. Let's try this one more time. F of negative 3 is going to be equal to our remainder, which is 6. Right. So you can use synthetic division to evaluate a function, or I mean, I think it's really smooth. I like it. It's just fun. It's just fun. Once you kind of get the rhythm, once you get the rhythm and you practice it a few, it really becomes second nature. Like it really doesn't take much thought. So the thing with like college algebra, I feel like the concepts are not difficult. The challenge with college algebra is organization and processing information overload, right? The real challenge is information overload. Remember, this is only a quarter of what we used to teach in the past in one semester, right? We took what we used to teach in one semester, broke it in half. So we got rid of half the stuff. Then we broke it in half again and broke those into 2 semesters. So the first half is the first semester. So between the 2 semesters is really only half of what we used to do in one semester, right? So, we, instead of doing like 1 section a week, we were doing at least 4 sections a week, at least 2 per meeting. But that involved and this was before I did pre-recorded lectures. So I would either like rush through stuff because obviously you would not have time to get through everything within 15 minutes. So I think it was a good move. But again, long story short, the challenge with college algebra is just, organization and processing information overload, learning. And the way you kind of mitigate that is basically by planning ahead, getting out ahead of the information as best you can. Because if you procrastinate, it piles up fast. Anyway. So, okay, let's keep going. So we're saying that f of negative 3 is 6. Again, we could use our calculator to check. I'm just going to use my prepared notes. Oh, we're already halfway. Party is almost over. What a bummer, right? And then I do appreciate that this class is only 50 minutes. Like I blink my eye and it's over. I'm a gamer. Like that's what my life revolves around right now. But I do like to do it whenever I want to do it, right? Like if I want a game, it's okay. If I want to do something else, I get some rest, or like be outside or whatever. I like my freedom. So hence why I really appreciate being remote. Let's keep going. Come on. There you go. So then we have the factor theorem. A polynomial f of x says x minus a is a factor if and only if f of a equals 0. So in other words, this is an application of the remainder theorem. If your remainder is 0, then we say that x minus a is a factor of our polynomial, right? If we divide the polynomial by the dividend and we get a remainder of 0, then it's a factor. All right, and it divides evenly. Let me check on you guys in Zoom. So I'm saying, just check on people in Zoom. You guys are actually looking pretty good. Okay, I'm gonna let that be. Gonna go ahead and close up my attendance for today. Mark all his absence. Looking good. All right, present please. So that way, if somebody comes late, I'll get them. Okay, so let's see this in action. Oh no. View settings, seamless. View settings, single page. Okay, let's keep going. I can minimize this for now. So given that 2 is a 0 of the function, solve the polynomial equation. Right? It set it to 0. So they gave us 1, 0. So then what we can do is let's go ahead and confirm that 2 is indeed a 0 of this polynomial, right? By using synthetic division. So if 2 is a 0, that means when we put it in a chair, we should get a remainder of 0. We get 3, 2, negative 19, and 6. Okay. Let me see. 3, 2, 1, 0. So every power is accounted for, so we don't need any placeholders. Again, the first number just comes down. On the diagonal, we multiply, then we add, we multiply, we add, we multiply, and indeed we get our remainder of 0. Okay. Let me see. So I was going to do something, but I'm noticing we started with a degree 3. That means our depressed equation is now a degree 2, 3x squared plus 8x minus 3. I was going to try to factor it, but let me try synthetic division. So sometimes our zeros occur more than once. That's where we had in the previous section talking about multiplicity. So I'm just going to test to see if 2 is a 0. I mean, I guess maybe factoring just might be more simple. Let me actually just factor this guy. Let me see. 3, 6, that's what? 14, yeah. So 2 is not another 0. Let me just factor, right? Because we have a quadratic, so we can factor. I'm looking for 2 numbers that multiply to give me negative 9 and add to give me 8. So I'm thinking it's negative 1 and 9, right? Okay. So I'm going to use the box method of factoring. I guess I'll do it in purple here. Let's do dark gray. So the box method of factoring, first I use the AC method because I said A times C, so the 3 times negative 3 to give me negative 9. Let me see, in the main diagonal, we do our leading term, which is 3x squared, and our constant, which is negative 3. And then on the off diagonal, we're going to rewrite that 8x using the 2 numbers that we just found. So we got 9x and negative x, okay? So then when we go to factor, if we look at these 2 on top, we ask ourselves, what's the greatest common factor? What do they have in common? They both have what? 3x. So we can factor out 3x from those 2 terms. Okay. When we look at the 2 on the bottom, what do they have in common? Well, we can factor out a negative 1 from both of those terms. If we look at the 2 on the left, what can we factor? X. I think we can factor out x from both of those terms. And if we look at the 2 on the right, what do they have in common? Looks like 3. We can factor out a plus 3 from both of those guys, okay? So our claim is that 3x squared plus 8x minus 3 factors into, let me move this guy. I'm just gonna move it like just over to the side somewhere. That's fine. So I can give myself some space here. So our claim is that it factors into 3x minus 1 times x plus 3. And then we don't forget that we already confirmed that 2 is a 0. So we still have this x minus 2 equals 0. I think this is the fully factored form of the original. We have our 2, and then we factored our depressed equation into these guys. So then if we use a 0 factor property and solve each 0 factor, we get x equals, looks like there's a negative 3, 1 by 3, and 2. Okay. Okay, that's fine. And then I'm just going to check. I'm tempted to just use my calculator. This one. Thank you. Reload and refresh. Okay. So then in my y equals, I'm going to put, we got 3x to the power of 3 plus 2x squared minus 19x plus 6. Okay. Then I'm going to call on that function. Let's evaluate it when x is -3. We should get 0. Calling that same function evaluated at 1/3. We should get 0. And evaluate it when x is 2. We should get 0. Right. So we confirm that these 3 results indeed are zeros, or the solutions, or the zeros of the equation of the polynomial. Okay. So given that 2 is a 0, since 2, we confirmed it, since 2 is a 0, we got a remainder of 0. So then we just factored, right, 3x squared plus 8x minus 3, and then we got those same results. The combined petroleum consumption in quads by a group of the most economically developed countries in the world during 1996 to 2011 can be modeled by this function, where x equals 0 represents 1996, x equals 1 represents 1997, and so on. The model indicates that C of 5 is 238 quads of petroleum were consumed in 2001. Find another year between 2001 and 2011 where the model indicates 238 quads of petroleum were consumed. Okay, I need some space. Select, duplicate, cut. Hopefully this works. Okay. Paste. It looks great. All right. Let me get a copy of this. X equals 0 represents 1996. Find another year between 2001 and 2011. The model indicates 238. So we want to see what's another year that this petroleum consumption is equal to 238 quads. So we basically said it's equal to 238 and so on. Maybe if I do this, sometimes this works too. I just want to paste. I knew it was on the clipboard. I was like, don't try to play me. All right, it kind of changes size rapidly. Okay, that's good. Okay, so we want to find another year where this is equal to 238 quads. Give me a moment. Okay. So I think I'm just going to do synthetic division here. I'm just trying to think of the simplest way. So for instance, if we do 238, this thing is hot. Let me unplug it. So if we do 238, all right, we should get let's just see what happens. I'm not going to say 3, 2, 1, 0. Is that missing an X? It looks like it's missing an X. I think there's supposed to be an X here. Yeah, I think there's supposed to be an X there. I really should subtract 238 and set it equal to 0. I just kind of want to use this. Let me say 0.021, negative 0.973. And then like I'm trying to avoid like these numbers, but you can't get around it. So 11.347 and then 202.965. Okay, so if we do synthetic division on this, let me go with my intuition and set this to 0. So remember, we had this set equal to 238. So if we subtract 238 from both sides, hey Google, what's 202.965 minus 238?
202.965 minus 238 is minus 35.035.
So now our remainder should be 0, all right? So the 0.021 comes down. Hey Google, what's 238 times 0.021? Let me just use my calculator. Let me see. 238 times 0.021. We get 4.998. And then we're going to say minus 0.9473. Sorry, 973. 4.025. We're going to say times 238. Nope, that's not an 8. We get 957.95. We're going to say plus 11.347. We get 9. Ooh, something's off. 3, 2, 1. Okay, I see. I know what I'm doing wrong. Let's back up. So 5 was actually supposed to be in the chair. Let me back up. We said after 5 years, we got 238. That's why I was pausing. I was like, what is off? I couldn't figure it out, but we got it now. This is the first 0 occurs when X is 5 after 5 years, right? Let's do that. That feels much better. Okay. I was like, what is going on? I had to think about it. So now it's like every time we get close to like it's getting ready to time to go, my brain just shuts off, right? Okay, let's try this again. So we're gonna say actually the 0.021 just comes down. On the diagonal, we multiply, so 0.021 times 5. Okay. 0.105. And then we're going to say minus 0.973. we get a negative 868. Then we're going to say that times 5. 4.34, negative 4.34. Then we're going to say plus 11.347. So, yeah, that's right. 7.007. And then we're going to say times 5, 35.05. 035, I mean. And so we get a remainder of 0, right? So that was confirming. My device is just like, hell no, we won't go. Come on. I'm trying to wrap this up. Yeah, fully paying attention. I think it's like overheating. I just want this. Way too difficult for no reason. Let me just try to finish this out. Okay. Now we could use a quadratic function at this point because now we're at a degree 2 polynomial. Let's do synthetic division again with 5 to see if we get a 0 remainder. No, let's just do the quadratic formula. I think that's the simplest way to go about this. Right? So quadratic formula, the negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m., right? That's the way one of my students remembered it, and I don't know, it's just easy for me to remember that. Okay, let me see. So our A, this is our A, this is our B, and this is our C. So then negative becomes 0.868 plus or minus square root of 0.868 squared minus 4. Our A is 0.021 times our C, 7.007, amount of space. So we're taking the square root of all of that, all over 2 times is 0.021. Okay, let's try to crunch this number. Okay. So let's do the numerator. We got this 0.868. Let's do minus the square root. We got 0.868 squared minus 4 times 0.021 times 7.007. Okay. Let's close off that square root and close off the numerator. We're going to say divided by 2 times 0.021. Okay. So we get this result, 11 years. Let me check it with the plus real quick. I think the plus we get a funky. Let's do the plus. So either 11 years, 30 and a third years, right? So let's see later. So we got 11 or 30.3 bar, right? If x equals 0 is the year 1996, x equals 5 years later was what? 2001. So then 11 years later, 2007, and 30 years later, 96, let me see, 06, 16, 26. Okay, let's go back. It says, find another year between 2001 and 2011. 238 quads of petroleum were consumed. So 11 gave us the year 2007, right? So that's what we're going to go with. Can I paste? No? Okay, that's okay. All right, I want to say that there is actually more in this section that's really important. I probably should have skipped this one in hindsight because it ate up precious time that we didn't have. But that's where our pre-recorded videos come into play. You definitely want to, because if I do a quick scan, let's see, we got the year 2007. View, seamless, view, single page. So they got 2007 as well, okay? Because the 30 was just too far out. The rational zero test, this is definitely something that you need to take a look at. So I'm going to have to piggyback off my pre-recorded lecture. Okay. What the rational zero test does is gives us a list of possible rational zeros. So like when we're trying to solve a polynomial equation, necessarily equal to zero, we can use the rational zero test to give us a list of possible rational zeros to start with. So that way we can try to narrow down quickly to find our zeros, right? And then once we get our zero remainder, we're good to go. But I'm going to have to rely on my pre-recorded video. Are there any burning questions before we go our separate ways? Going once, going twice. Okay. All right, so if there aren't any burning questions, we're actually going to go ahead and end the session here. From one beautiful mind to another. Enjoy the rest of your evening, guys. And we'll meet back on Wednesday, same time, same place, to go through as much of the homework together as we can. All right, guys, take care. Enjoy your evening. Peace.